Good afternoon.
Hello,
Hello,
Christine.
How are you doing today?
Well,
Well,
caffeine hasn't quite kicked in yet.
I hear you. I ran out of coffee creamer, so I had to run me and my kids over to Starbucks. Otherwise, my head was going to explode.
Oh no, panic.
But I got good news, though. I just finished my statistics final, and I got 100%.
Oh, congratulations. Outstanding.
Yay! Thank you.
What's your degree program?
I'm doing human services and social work.
Oh, and you had to take a stats class?
Yes, I did. It was I had to take it to be able to transfer so I can start my bachelor's. So I have you and I had Miss Collier.
Okay.
So you were my last professors at COS.
It's too bad it had to be online.
Yeah, I know. I would rather be in class.
Where are you transferring to?
I'm not 100% sure yet. I'm still trying to figure out all of the COVID stuff too with my kids. I have 8 of them here. So as far as I know, we live in Hanford. So as far as I know, they're going to be opening up the schools. So if they open up the schools and it's normal, I can actually figure out where I want to go.
What kind of social work you want to do?
I'm not 100% sure. My inspiration was actually my children. I have I have 4 out of my 8 kids have a disability. So I was thinking about doing something along those lines, but I don't know yet.
I'm not trying to get personal here. Are they all your children or are they foster children?
Well, I have 5 biological children. My second son passed away in 2009.
Oh.
But I have 4 stepkids. So I have 2 from my previous marriage. Sorry, I didn't realize my camera was off. I have 2 from my previous marriage, and I have 2 from my current marriage, and then I have 4 stepkids.
Wow.
Yeah. So we kind of have an influx of kids in and out of through the weeks because we have 50% custody with my stepkids, so it's week on, week off, and then my ex-husband has visitation on the weekends, so I have them during the week, and then my 2 youngest ones I have all the time.
Oh my gosh.
So yeah.
I cannot imagine that kind of daily schedule.
Yeah, it's pretty hectic around here, but we get through it, and it is what it is.
I am very grateful there are people like you in this world, Christina.
No.
The people that I work with in the emergency room, some of the ones I have the most respect for are the social workers.
Yeah.
Because essentially what I do is put Band-Aids on boo-boos. They get to deal with all the drama.
Yeah, there's a lot of drama out there.
Yeah, and it's pretty extreme in an emergency room.
Yeah, I actually started going when I first started at COS, and my first semester was in spring of 16, and I started out with physical therapy assistant, and I had Dr. Moore, who was my teacher. And so she actually told me, she called me in her office one time, and she said, Christine, she says, I have 3 kids and I can't imagine how many lunches you make every day. And she says, because I was kind of not falling behind, but it was just really hard because of the material. We had labs to do, and then we had all of it. And so I finished her class with a B+. But she told me, she said, that there's only a certain amount of students that get into a program, and you have to be one of the top students or whatever. And so she told me that that she's extremely happy to know me and all that I do. And she can't imagine the stress I'm under. And she wanted to congratulate me for getting the grade that I got in her class just because of the amount of kids that I got.
Well, that was nice of her to recognize that.
That was really nice of her. It made me actually feel really good. And then I decided, maybe physical therapy, and maybe that's not what I should be doing. Maybe I should be doing something else.
Well, you have completely validated my teaching history in all the years I've been teaching. Typically, the best students in any given class that I've ever taught tend to be, and this may not exactly describe you, but you're close enough, 30-something single moms. Those
Yeah.
are my best students. I attribute it to them being more motivated than the average student. Many of them have jobs. They're juggling childcare plus all the sandwiches they got to make,
Yeah.
their studies and whatnot, and they don't have time to fail a class and then have to
Yeah.
repeat it. So even if they don't like the subject, even if it's boring to them, if they think it's really hard, they will do what it takes to at least pass the class. And
Yeah.
I respect that. I have a lot of respect for that. And over the years, they've typically been my best students.
Well, yeah, I really do hold my grades and getting everything done to a very high level, because I don't have just class to do. I have kids and I have a husband and I have a house and I have, I have to keep my kids on, and all of my kids need help. And I have my oldest daughter, 16, and she's autistic. And so I have to, get her settled down. And I have a son that has ADHD with a behavioral disorder, and and he's actually home right now. So I'm just like, oh,
Oh boy.
yeah. And I did my statistic. I actually just now finished that final with my 4 kiddos home.
Well,
And
something tells me you're going to be a very successful social worker.
I think I will. I juggle my calendar very well. And I'm very grateful for my iPad.
I think in order to be successful as both a parent and a student, you have to have really, really, really good organization skills.
Mm-hmm.
You know what, a skill, skills that are, I think, successful strategy for any student, and I think you're practicing them. One, you do have to have really good time management skills if you're to be a successful student.
Oh, definitely.
Yeah, because some of the younger students, they're under pressure to participate in daily life, and so their time management is skewed. Let's put it that way. So typically, these are the people that will write the paper on Sunday night, and so you got to have time management skills. And the second skill that I've always thought necessary for a successful student is you have to, and I know this is going to sound strange, but you have to have a skill at being able to take notes. And the reason is that if a student approaches me asking for, say, a letter of recommendation, it is one thing to have a high GPA. Say you have a 3.6 or higher GPA. If it's a real 3.6, meaning, you didn't take a bunch of professors who were willing to give you a grade just because you turned in a bunch of paper, okay? If it's a real bona fide 3.6 GPA, there's something else that it tells me from my point of view. In order to get a 3.6 GPA, you not only have to have something on the ball up here, you do have to have really good time management and note-taking skills in order to do that. And by note-taking, most of you in this class have had a wide enough variety of professors. We're human, we make mistakes, and you get the professor who rambles on and on and on about his personal life, and then you get one that constantly goes off track, and then you get one that just literally reads his notes to you. And so you get this wide variety of personalities. And you as a student have to learn how to put the pen down because the instructor is off topic. And then you have to learn when to pick it up and start writing again. The other thing is you have to listen and pay attention, because when we were in a classroom, there's a lab component associated with this class, and it's not required, but there is a lab class associated with this class. And during the lab portion of the class, I would encourage students to work in groups, and I would allow them to use their notes and their books. And I would wander through the classroom, assisting them in any way that I could. But the students oftentimes, because they could use their notes and their books, everything was laid open on the table. And I would be walking around the room helping students, and I would glance at their open notebooks. And I am not exaggerating when I tell you that in lecture, I could have told them that the sky was blue, and somebody in their notes said, he said the sky was yellow. I'm like, where the hell did you get that at? And, you know, they wonder why they struggle with exams, because they don't listen in lecture, and they write some really crazy stuff in their notes. The third skill you have to have, first one is time management. Second one is note taking. There's a third skill that you got to have here. And when it comes to studying any subject matter, you have to put your ego aside and not be afraid to make a mistake. And what I mean by that is when you study for material that you're unfamiliar with, reading the book over and over again does not do it. Rewriting your notes over and over again doesn't do it. All that does is get you to memorize a couple of factoids. That's it. You don't understand the material. So what you have to do is, and typically this is where you get together with other students in the class, the best way to know new material that you're unfamiliar with, explain it to somebody else. You will make mistakes, but at least you'll know, and you'll know hopefully what to focus on. And eventually you'll understand the material, because rereading it over and over again doesn't do it. Mm-hmm. And the most humorous one I've ever noticed, and probably the worst invention ever for students, is that damned highlighter pen. How many times have you purchased a used textbook in the bookstore and virtually every page is like bright yellow or bright pink, and you had to be thinking, what was this person doing? And so, no, the highlighter pen is the absolute worst study aid on the planet. Mm-hmm. Ugh.
Well, like you were saying, that the last thing about telling somebody else, or you know, explain it to somebody else. I actually, my mom has been a Star Trek Babylon 5 fan forever, and she gets a
woman after my own heart.
She gets a kick out of everything space and stuff. And so I called her up and I said, Mom, you have got to hear this. And I pulled my notes out and I said, did you know? Da 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 da. She's like, really? Oh my gosh, that is amazing, you know? So I actually went through and I explained a lot of stuff to her, and I talked to her about the Sierra Nevadas and how it's granite and it heats everything up. And she's like, that is so fascinating. So I pretty much gave her a lecture on what you have been lecturing on. And I usually do that. And since I have so many kids and they're between the ages of 16 and all the way down to 6 years old, I tell them my material every semester, whether they want to hear it or not.
That's actually helping you tremendously, because it is. Mm-hmm. When it's like, for all of you who are actually listening to this conversation between Christine and I, at various times in your college career, you are going to be asked to write a paper. Mm-hmm. And it's a common problem where students run into writer's block. And the problem with it is, and listen up everybody, because you are going to have to write papers at some point in your college career. And it's going to be everything from a little dinky 3-page to a 20-page, maybe 30-page, fully annotated with bibliography. You're going to have to do it at some point or another. And here's the trap that most students fall into when they attempt to write a paper. They think that they have to have it all worked out in their head before they actually put word on paper. And that's just not true. The best writers on planet Earth can't do it that way. So here's what you do to start. Whatever the topic is, everybody, whether you're familiar with it or not, you are not going to make sense of it in your head all at once so that everything that you type out is perfect the first time around. That ain't happening. It's a dream, folks. What you got to do is whatever the idea is in your head on the subject matter, just throw it out there on the paper or on the computer screen. It's gonna look silly to you. It's not going to make sense, but you need to see it by looking either at a computer screen or a piece of paper. It doesn't make any difference. You've got to get those words out there. Then you rearrange them. Don't do it in your head. Get it out there first. Then work on organizing it, because it's only then that you're going to see, oh, hey, I'm missing something. I need to add this, or I need to remove something because it's, it's basically bullshit. You got to get it out there and then worry about it. So when you read something out loud, or if you repeat something out loud that you've heard in lecture, even if you're talking to your children, you are hearing these words, and be honest with yourself. Does it make sense? Do you really understand what it is you're talking about? And even though you're talking to children, it doesn't make any sense. It doesn't matter. You need to, it's like, it's the verbal version of getting it out on a piece of paper. Mm-hmm. And when you talk it out like that, maybe the kids don't completely understand what you're talking about, but you're hearing yourself say these things. So yeah, that's what you got to do if you want to learn new material, if you want to get that paper out there. And if you are going to write a large paper, everybody, say a 20-page paper, and you need to fill in a bibliography, I'm going to give you a little trick of the trade here, folks. When I was a grad student, oh my gosh, my very first semester of grad school, I vividly remember turning into that man 800 pages by the end of the semester. It was brutal. So what happens is you learn how to write, and you learn how to write efficiently. So if you're going to do a 20-page research paper for some class in the future, everybody here, here's a trick of the trade. Either go to the library or whatever you guys do, go online, something like that. Find a single article that you feel hits, whatever topic that you're doing your research on, whatever that is. Find that one single article that, hits the nail on the head, so to say. It's what you need for this paper. And then go to that person's bibliography at the end of the article. You will save yourself hours and hours of research time. Take it for what it's worth, folks. A little trick there. Just find that one article and go straight to that person's bibliography, and you just save yourself a lot of library time. All right, let's get started, everybody.
Recording in progress.
Okay, before I get going on the material, I just want to bring something up real quick here. I still have one or two, maybe three students who are having issues receiving PDF files and accessing the recordings. Now, I believe the other day we talked about it, and there was a couple of students who were having similar issues, and they were able to figure it out. If there are any of those students here today, could you let us know again what it is you did to straighten out your problem with opening up the recordings or downloading the PDF files? Does anybody here remember that? No?
Yeah. Do you mean what we talked about yesterday?
Yes.
Oh, what I had said was I noticed that when I copy and pasted, I was accidentally copying and pasting where it said the password part too. Mm-hmm. So you have to pay attention to that and only copy and then paste just the part that's the link, and then go back and either copy and paste the password or write it in. Yeah. So
okay.
Yeah. So that was that. And then I don't know what the issue with the PDF is, though. I didn't have a problem with that one.
Okay. Yeah, there's still like two students in the class who have repeated issues with that. So we're trying to straighten it out. So any little help, to give them or advice. It seems to work whenever they do mail. If they respond to me, if they send me a message saying, hey, I didn't get yesterday's handouts, and then I reply to that one single message, it seems to work. So I'm wondering if there's an issue with it being a group message. I'm not sure. So in the future, everybody, if you're aware of the fact that something is being sent to you, like I've told you, hey, tomorrow I'm going to send you some handouts, or I'm going to send you the exam, and you don't see it show up, then by all means, please email me and message me and say, hey, look, I didn't get it. Because what's happening is that when I respond to that one single message, it seems to work just fine. Okay. So, let's hope we get it all fixed, so that I can send everybody a group message. But if that happens where, that something has been sent, but you haven't received it, it seems to work when I respond to your one single email message. I don't know why, but it does. Okay, let's finish up the material here, and then I'm going to go over exam 1 with you. Okay. I was talking about systems yesterday. Before I finish this section of material, does anybody have any questions about anything I said in yesterday's class? Nope. Okay. So, systems. Reminder, there's 2 systems. It's either open or closed. An open system has both an input and an output. That's the definition of an open system. A closed system, on the other hand, has 3 potential scenarios. The first one is no inputs, no outputs. The second one is it's got an input, but no output. The third one, no input, but yes, it has an output. Those are closed systems. There's only 2 kinds of potential inputs and outputs of any kind of system. That's either matter or energy. Strictly speaking, everybody, matter and energy are actually one and the same thing. It has been proven over and over again. Matter is nothing more than frozen energy. So the couch that you're sitting on, and the chair that you're sitting on, and the dinner plate that you're eating off of, this is all frozen energy. How do you know that, everybody? All you got to do is like, say, that wooden chair that you're sitting on, that's frozen energy. Well, throw it in the fire and you will release that energy. How? You will sense it in the form of heat. Okay, so in the case of an open system only, you have 2 kinds of feedback loops. You do not see this in a closed system, only an open system. A positive feedback loop promotes growth. So the ecosystem gets physically larger. Your body gets physically larger. The second feedback loop is a negative feedback loop, and I said that it maintains equilibrium. So whatever size you have achieved, the example I gave yesterday was you personally. So whatever size you achieved by the age of 18, that was roughly going to be the size you were for the rest of your life, because your endocrine system is functioning in a negative feedback loop. It's maintaining your body in all of its various parameters. And that includes height, size, weight, and all of that. Ecosystems function the same way. So the tropics only extend to those 2 dotted lines on the map, 23.5 degrees north latitude and 23.5 degrees south latitude. You don't see tropical rainforests growing outside of those two dotted lines, okay? So these were systems and feedback loops. And Christina, you can bring something up here with your mom that should interest her when it comes to the concept of systems. There is actually some very vigorous debate on whether or not the entire universe is either an open or a closed system. Because if it's a closed system, the universe is set to die. And if it's an open system, then here's the big mystery. Where's the input coming from and where's the output going? And believe it or not, there's a lot of MIT and Harvard professors discussing this very topic. They want to know. Okay. So what I'm going to do now is go over the exam, okay? And what I need you to do is there's not going to be any problem solving on there, okay? So what I'm going to do is straightforward, get to the point on the study guide itself as it relates to the test. So here we go. Yes, you will need to, I'm looking at the study guide, everybody. You will need to know the dimensions. The Earth is 24,000 miles around. That's its circumference. Its diameter is 7,900 miles wide. The shape of the Earth is an oblate spheroid. It's not a perfect circle, everybody. Oblate is your $64 college word for the week. It is a fancy way to say flat. So where is the Earth more flat? Well, it's more flat at both polar regions and it's spherical at the equator. Okay, so the shape of the Earth is an oblate spheroid, and the word oblate is spelled O-B-L-A-T-E. The rotation of the Earth and ocean circulation, Earth rotates in an easterly direction, as does virtually all the planets in the solar system, with one exception. Venus rotates in the opposite direction of everybody else in the solar system, and that's a rather curious anomaly because that's not naturally how things happen here. So we believe that Venus suffered a major impact at some point early in its history and literally reversed the rotation of the planet. All of the planets in our solar system should be rotating in an easterly direction, and they do, with the exception of Venus. But because our rotation heads off in an easterly direction, ocean currents at the equator are going to move in a westerly direction, and they do. So water is going to leave the coast of Africa. It's going to head towards South America. Once it hits the South American coastline, it's water, so it's going to divide. And the water current that heads up in the north is going to rotate clockwise. Water currents that head down south are going to rotate counterclockwise. So ocean circulation in the north is clockwise. Ocean circulation in the south is counterclockwise. That's really, really important, everybody, because it heavily influences the local climate in your area. Ocean circulation in the northern hemisphere rotates clockwise. So in the case of the Pacific Ocean, it's going to leave the coast of Ecuador and it's going to head towards Asia, where it will split just like it does against South America. Ocean current in the north is going to rotate clockwise up north along the coast of East Asia. And then it's going to make another hard right-hand turn as it swings underneath Alaska. And then it's going to come down the coast of California. And by the time it comes down the coast of California, that water temperature has cooled down quite a bit. And it is about 65 degrees off the coast of Monterey. And I don't remember anybody in my personal life telling me that they went swimming in Monterey Bay in their birthday suit. This wasn't happening. That's cold water. How does that impact our weather here in the Great Central Valley? Well, it's cold water, everybody. Cold water does not evaporate easily. So the air that passes over that water is not able to absorb a whole lot of moisture. And what little bit that it does absorb, a lot of that ends up falling on the Pacific Coast Range before it passes over the Great Central Valley. So if you've ever driven over Pacheco Pass to get to the coast of California, and many of you have, you've noticed that once you got over Pacheco Pass and started coming down the other side, you have just driven over the Pacific Coast Range. And the side of that mountain that is facing the ocean is green. It's a lush forest because most of the moisture that the air picks up over that ocean off the coast of Monterey, it's going to drop on that mountain range. And the little bit that is left over is what we get here in the Great Central Valley. And we only get about 11 inches of rain a year. Land distribution. Most of the dry land on the planet is located in the north, not the south. Because of that, the wind speed in the southern half of the planet is quite a bit faster than it is in the north. You see, dry land has a tendency to slow wind down. It acts like a speed bump to the wind, everybody. If you're out in the open ocean and it's a windy day, it's typically really, really windy because there's nothing to slow the wind down. The water doesn't do it. It's flat. Well, relatively flat. So as it passes over dry land, it slows down. Well, most of the dry land is located in the north. So the wind speed in the southern half of the planet is noticeably faster than it is up here in the north. Land-water ratio, 29.4% of Earth's surface is dry land. 70.6% is water. There is this misconception, everybody, that we are a water planet, and that's just not true. Earth, relative to the entire size of Earth, everybody, actually has relatively little water. The water that we do have, the vast majority of it is on the surface of the Earth, not inside the Earth. And so when you look at the total volume of Earth, we're actually dry. It's just that the water that we do have happens to be on the surface, that's all. But 70.6% covers, well, the surface of the Earth is covered by water, okay? Orbital characteristics, our Earth-Sun relationship here. We go around the Earth on what's called the plane of the ecliptic. If you were to look at the solar system edge on, like this, okay, all of the planets would merely appear to you to move back and forth like this, even though they're going in a circular orbit around the sun. That's what it would look like to you if you looked at it edge on. That line is the plane of the ecliptic, okay? So when I tell you that Earth is tilted 23.5 degrees, well, what was it 23.5 degrees from? From the plane, or from the perpendicular, okay? 23.5 degrees from the perpendicular. Here's the plane. This is perpendicular. If you remember last week, I explained that the word perpendicular merely means a 90-degree angle. If you ever hear anybody use that word in conversation, in a math class that is, it merely means that something is at a 90-degree angle, okay? So the Earth is tilted 23.5 degrees from the perpendicular. We're not straight up and down, okay? As we go around the Earth, And these questions are going to show up in the matching section of the exam, okay? You are going to need to know 5 lines of latitude. You're going to need to know that 0 degrees is the equator. 23.5 degrees north is the Tropic of Cancer. 66.5 degrees north is the Arctic Circle. 23.5 degrees south is the Tropic of Capricorn. And 66.5 degrees south is the Antarctic Circle. Okay? They will show up in the form of a matching question. Okay? And as we go around the sun, our orbit is not circular. It's slightly elliptical. So at some point in our orbit, we are physically furthest, and at another time, we are physically farther away. So there's some dates that are going to show up on the exam that you need to be familiar with, and they are June 21st is the summer solstice. We just passed it. It's the longest day of the year in the northern hemisphere. If you live in Australia, everybody, June 21st is your shortest day of the year. Okay? The second date I wanted you to know was December 21st. It's our shortest day of the year. It's Australia's longest day of the year. And then I wanted you to know 2 dates that are associated with Earth's orbit in that elliptical orbit. We're coming up on July 3rd. And on July 3rd, it's on your study guide, everybody, we are at aphelion. Earth is at aphelion in relation to the sun on July 3rd. And what that means is we are physically farthest away from the sun. We are 94.5 million miles away from the sun on July 3rd. On January 3rd, we are at perihelion. We are physically closest to the sun. And on that date, we are 91.5 million miles from the sun. The number of 93 million miles that all of you were taught in elementary school is an average number. Okay? So the reason Earth has 4 seasons, everybody, is precisely because we are tilted at 23.5 degrees from the perpendicular. If you take 90 and divide it by 23.5, it's not exact, but it's pretty close. You come up with 4. So that's why we have 4 seasons. If the Earth were sitting straight up and down, perpendicular to the plane of the ecliptic, you wouldn't notice any change in seasons. It would constantly be either summer or winter, whatever location you happen to be in. There wouldn't be a change in seasons. If the Earth were tilted at 45 degrees, well, then there'd be 2 seasons. I've always wondered what we would do if say, for instance, let's say the Earth was tilted at 15 degrees or something like that. There'd be like 5, maybe 6 seasons. So what would you name them? You'd have to come up with two additional names besides summer, winter, fall, and spring. Anyway, so on the study guide, I'm looking at number 3, latitude lines. Once again, you needed to know those 5 latitude lines. You needed to know their degrees and their names, okay? latitude lines run this way on a map, sideways. However, this is the confusing part to people that have never had any kind of geography class before. The lines on a map run this way. Latitude lines run this way. They are latitude. They run laterally. However, they're measuring this distance. That's the confusing part. They measure north-south. It goes from 0 to 90 degrees. 0 is the equator. 90 degrees is the polar region. It's the North Pole and the South Pole. Okay. Latitude lines are also known as parallels because all latitude lines are parallel to each other. Okay. To give you some idea, and I did mention this earlier in lecture, to give you some idea of the distances involved here, California, our border with Mexico is located at approximately 32 degrees north latitude, and our border with Oregon is 42 degrees north latitude. So California is 10 degrees in latitude tall. If you've ever driven the entire length of California, then you know what it's like to cover 10 degrees of latitude. There are countries on this planet that have more extreme distances involved, and it really wreaks havoc on that country's economy, because the country of Chile, the northern border with Peru, is located at 10 degrees north, no, at 10 degrees south latitude. The border with Peru, the northern Chilean border with Peru, is in the tropics. It's at 10 degrees south latitude. The southern border of Chile, the very southernmost portion of Chile, is located at 55 degrees south. That country is nearly 5 times as tall as California. And so when you drive to the northern part of Chile, you're in the tropics. And when you drive to the southern part of Chile, you see icebergs. That's how it wreaks havoc on their economy. Most of their economy takes place in the very middle of the country, because that's where the climate is most moderate. Solar angle, everybody. Again, there's not going to be any problem solving on there, okay? But what you need to know about solar angle, it's the angle of sunlight that you receive at noon. That's when the sun is highest in the sky. What I told you is that in the case of Visalia, on June 21st, which is our longest day of the year, the sun will get to be 77 degrees above the horizon over Visalia. And then on December 21st, when it's our shortest day of the year, the sun will only get up as high as 30 degrees above the horizon. And so it's a short day for us because the sun is not in the sky long enough. So we have a short day. Okay. So the reason for the change in seasons, everybody, has nothing to do with the changing distance from the sun. The reason for the change in the seasons, everybody, is solar angle. Yes. It changes on a daily basis. It changes. The average temperatures, the difference between the north and the south has a lot to do with how much of the southern half of the planet. You remember me telling you most of the dry land is located in the north. And therefore, in the southern half of the planet, most of it is water. And the temperatures in the south are more even than they are in the north. In other words, by even, what I mean is the change in temperature between summer and winter is not quite as drastic as it is in the north, because we have most of the dry land up in the north. And so our temperatures, the difference between summer and winter could be huge. If you live inland in Kansas City, you will experience a 0-degree day in the winter, but in the summertime, you will also get to have a 95, possibly even a 100-degree day. That's a 100-degree change between winter and summer. But if you live near water, if you live in San Francisco or Monterey, Visalia is not near a large body of water. But if you go to Monterey, the difference in temperature between winter and summer, the change is only about 45 degrees. And so water moderates your change in temperature. And there's more water in the south than there is in the north. So the overall pattern of temperature changes in the south is much more evenly distributed than it is in the north. Longitude lines, everybody. These are the lines that go up and down, but they're measuring this distance here. Longitude lines are measuring an east-west movement. They go from 0 to 180 degrees. There were 2 longitude lines that I asked you to know for the exam. 0-degree longitude line is the prime meridian. It's located in Greenwich, England. And the only reason it's located in Greenwich, England, is because the man that's built this clock to calculate longitude, that was his hometown. So that's the only reason that line runs through Greenwich, England. There's no physical reason why it should be there. The 0-degree line could have been anywhere. The second longitude line I wanted you to know was 180 degrees longitude. It is the international date line. And as sheer chance would have it, everybody, it divides the Pacific Ocean in half. And that is a rather fortunate coincidence in human history, that the man who built this clock lives in England, and the exact opposite side of the world from him is the middle of the Pacific Ocean. And what I mean by that is, and I mentioned this to you earlier, suppose the guy that builds that clock is from somewhere in Southeast Asia, and they run the 0-degree line through his hometown. Well, the opposite side of the earth is where the 180-degree line would be, and that would end up cutting, parts of the United States would be in one day, and another part of the United States would be in another day. How confusing would that be? So it's just by sheer coincidence, dumb luck, if you want to call it that, that it happens to cut the Pacific Ocean in half. I mean, who cares? Okay. And up until the Second World War, most of you are familiar with the fact that the country of Japan, their symbol on their flag is the rising sun. Well, the planet rotates in an easterly direction. So up until World War II, everybody, there was approximately 50 independent nations on planet Earth. And of those 50 independent nations, the country of Japan saw the light of the sun on every day. They were the first ones to see the light of a new day every day. So that's where the land of the rising sun comes from. However, since the end of World War II, everybody, we have added, humanity, I should say, has added an additional 160 additional independent nations. So in 1945 to 2021, we went from 50 to 210. Does the 6 o'clock news make a little more sense to you now? Anyway, Some of these 210 independent nations are little tiny islands located out in the Pacific Ocean, and it is now the island of Kiribati, which is located very near the 180-degree line, and it's the first independent nation to see the light of a new day every day. And so now they are officially the land of the rising sun. Once again, there's going to be no problem solving on the test. However, you need to know that longitude lines go by two names, either meridians, and when you use the word meridian, you're talking about a time zone. The second phrase is a great circle path. The shortest distances between 2 points on a round object, and I hope there's no flat earthers in the class, but I'm sorry to tell you this, but yeah, the earth is round. And the shortest distance between 2 points on a round object is not a straight line. It's a great circle path, okay? You need to know that each time zone is 1 hour wide. It is also 15 degrees of longitude wide, and it is 1,000 miles wide. So let's just say if 135 degrees separates you from, say, your family, how many hours of time is between the two of you? Well, 135 degrees divided by 15 equals 9. There's 9 hours of time between you and your family. There's also 9,000 miles between you and your family. Okay. The example I gave yesterday was Visalia and New York City. Visalia is located at approximately 120 degrees west. New York is located at 75 degrees west. That's a 45-degree difference. 45 divided by 15 is 3. So there's 3 hours of time difference between us and New York. There's 3,000 miles distance between us and New York. So that's how that works, everybody. Systems that should be fresh in your memory, everybody. Open and closed, only one kind or two kinds of inputs or two kinds of outputs. That's either matter or energy. That's it. Don't write anything else. It's just matter or energy, okay? It has to have both an input and an output in order to be classified open. Anything less than that, and it's a closed system. All closed systems die. Open systems do, in fact, have the potential for immortality. However, in order to do that, they have to function at 100% efficiency. And unfortunately for us, the human body is not 100% efficient. So we age. Okay. So the big mystery in the cosmos, as I mentioned earlier, is the universe an open or a closed system? We don't know yet because our telescopes are not powerful enough to see beyond what we call our light barrier. We estimate the age of the universe to be 13.8 billion years old. That's as far as our telescopes have been able to see. We can't see anything beyond 3.8 billion light years. Doesn't mean there's nothing out there. We can't see it. That's all. That's called our light horizon. That's as far as we can see. So the big mystery is that, is the universe infinite, or is there another universe out there? And if the universe is infinite, here's something, Christine, you can bring up with your mom. We don't know this, so it's all speculation. But if the universe really is infinite, then that means that somewhere out there, there's another solar system that is identical to this one. And that also means there's another Earth. And that also means there's another you. Is that bizarre or what? Because if the universe is infinite, then that's a very real possibility. Are you leading the exact same life that you do here? Probably not exactly the same. There's probably details that are different, but nonetheless, there's another Christine out there with 8 children. Okay, I am going to send the exam and the answer sheet to you tomorrow morning by 9 o'clock. There will be no Zoom meeting tomorrow because you will be taking the test. I need to have your answer sheets returned to me by Friday morning at 9 a.m. I will then grade the exams over the weekend, and I will contact you individually on your email account and let you know what your grade was. Okay? So I am sending the exam out tomorrow. If somebody for any reason doesn't receive anything from me, then go ahead and message me. And like I said earlier, for some reason, whenever I respond to that individual message, it seems to work. So no need to go in a panic. All you have to do is message me and say, hey, I didn't get it, and I will send it to you, okay? So keep an eye out for it tomorrow morning. And on next week, when we meet on Tuesday, that morning, I will be sending out all the material necessary for exam 2, okay? So unless anybody has any questions, I will see you guys next week.
Thank you.
Thank you so
Bye-bye.
much. Have a great day.
Bye-bye.
Thank you.
Bye.
Bye-bye.
Recording stopped.
I have a quick question for you.
Yes.
Okay, it doesn't have anything to it has to do with the other day when you were talking about Betelgeuse. Whenever when did they say that star was supposed to explode?
Well, in cosmic timescales, any minute now.
Okay.
But from the point of view of your lifespan, it could happen today, or it could happen sometime in the next few years. The problem is that that star is approximately 650 light years away from us. So if you think about it, it could have already exploded. We just haven't actually seen it yet because the light is going to take 650 years to reach our telescopes.
Okay. Yeah, because I was telling my kids about that the other day, and I told them about how it was, on Orion's belt, and like we have a swimming pool in our backyard, so we like to float around and look at the stars, and we point out the constellations and stuff, and the Big Dipper and Little Dipper, all that stuff. And so I was talking to my kids about that, and they asked me, they said, well, if it blew up, then will we still be able to see that star?
From the moment it blows up, whenever that is, the light that it radiates is going to take 650 years to reach us.
Yeah.
So if it explodes today, you're not going to see it.
Yeah, we wouldn't see it.
So the only reason you would see it at all in your lifetime means that the star, in fact, blew up sometime around the year 1300.
Okay.
And we are just now seeing the light from that explosion.
That's super interesting.
And
that's really
so
cool.
while you are looking up at the night sky, there's another interesting phenomenon associated with Orion. Betelgeuse is the right shoulder of Orion.
Mm-hmm.
Now, the stars located in the belt of Orion are somewhat difficult to see. You got to have a really sharp eye, or you just have to use your telescope.
Mhm.
There's 3 stars that make up that belt, and underneath the middle star, probably in terms of distance, it would be like the width of your finger below that middle star. And you do need a telescope to see this.
Yeah, we have a telescope here.
There's what looks like a smudge underneath that middle star. And it's the remnants from an old supernova explosion. And if you Google it, you can, the space telescope, the Hubble Space Telescope, is powerful enough to zoom in on it and get some really good photographs of it. But it is in photographs, it looks like a big, huge, multicolored cloud, but it's basically the leftover debris from that star that exploded. And it was actually witnessed by Chinese astronomers in the year 1054 AD. They recorded in their journals seeing a new star appear in the night sky. They did not understand that it was an explosion. They
Mhm.
thought it was the appearance of a new star, and they recorded seeing it. And then they also recorded that about 3 weeks later, it disappeared. And it wasn't until the 20th century and modern telescope technology that we were able to realize it wasn't a star per se, it was the explosion of a star.
Wow.
And it is called the Crab Nebula.
Oh, I've heard that before.
And so look it up. There are some really, really cool photographs of it.
Yeah.
And the core of that star has survived. It's about 10 miles across, and it is so dense. Imagine taking our sun and squeezing it down to the size of a city.
Oh my gosh.
That is what's left over in the middle of this explosion. And it's radiating energy powerful enough that it is lighting up that entire cloud of dust and debris that is about 10 light years in width.
Wow, that's
And that little 10-mile wide remnant is lighting up a 10 light year cloud. And there's pictures of it on Google.
Yeah, we will Google it. And then there was one other thing I was talking to my mom about, and you were talking about Jupiter and how fast it's spinning, and it's spinning so fast it's kind of just smearing the clouds.
Yep.
And I was looking through my notes to tell her how fast it was spinning, and I guess I didn't write it down.
Earth is spinning at 1,000 miles an hour. And
yeah, I know we are. Yeah.
Jupiter is 1,000 times larger than us, and its day is 10 hours. So it's rotating at tens of thousands of miles an hour. It's rotating faster than a rifle bullet.
Yeah, I was telling my mom when I was talking to her about it, and oh, there's my son. He was sitting on the other side of me while you were talking about that. He's going, "Oh my gosh, that's great. We love this stuff," So, so Jupiter. I was telling her about Jupiter, and I said, Mom, I said my professor said that it's spinning so fast that when we look at the pictures of it, it just looks like these just smears,
like a Van Gogh painting.
Yeah, so when I was talking to her about it, because that huge storm that's on it,
that storm will consume 3 whole Earths.
Yeah, that's what I told her, that we could fit, several Earths in there. But so it's spinning so fast and it's smearing the clouds around it, right? So it's pretty much the clouds don't have time to catch up with it, right?
No.
And so, but then the storm that's on there, and that storm is rotating in itself as well, right?
Correct.
And so that's also going
around the planet.
the planet as
Yes.
well. Oh my gosh, that is so
And
crazy.
Unfortunately, humans are never going to get anywhere near Jupiter. And the reason for that has to do with Jupiter's magnetic field. It's so intense that it would kill a human being.
Yeah.
And so the big mystery is we don't understand what's in the middle of Jupiter yet. We don't know if it has a solid core, because theory says that planets that are the size of Jupiter actually started out Earth-like, and they grew to be approximately 5 to 10 times the size of Earth. And then they started accumulating the gas around them and became these big, huge gas giants. So the mystery right now is we don't know exactly what the middle of Jupiter is. It a solid core, or is it something else? Recent discoveries are beginning to lead us in the direction of something else. We're currently leaning away from the idea that the core of Jupiter is a super Earth of some kind. We don't think that's true anymore. And the reason has to do with we've tried taking radar images of the planet to see through the atmosphere, but we're not getting a very accurate picture. And the radar is indicating to us that there's nothing solid in the middle. And so the new theory is that the middle of Jupiter consists of basically a large ball of hydrogen that is in the form of plasma. Which means it's really, really hot, and it's generating this magnetic field that essentially Jupiter's magnetic field is the single largest object in our solar system. If you had the ability to see magnetism, you would notice that Jupiter's magnetic field extends all the way to Saturn.
Oh my gosh.
It's absolutely huge, and it's so powerful. One of Jupiter's moons is called Io, and it is volcanically active. Its volcanoes are constantly spewing out magma. And because there's very, very little gravity on Io, the debris that it belches out just literally goes straight out into space. And the material is being picked up by Jupiter's magnetic field, and it's accelerating this material at speeds that are a sizable fraction of the speed of light. And so it's creating a zone around Jupiter that is basically highly, what do you call it? There's like nuclear radiation surrounding Jupiter. So it's, humans going to Jupiter is a no-no.
Yeah, no, I
Don't go there at all. As a matter of fact, any of the space probes that we do send to Jupiter, we typically surround them in titanium, because the life expectancy of a satellite orbiting Jupiter is relatively short.
Right, yeah.
And the radiation surrounding Jupiter eventually gets the best of the electronics, and then it's no good anymore. Another little interesting fact of our solar system, the second largest planet in our solar system is Saturn. And a good backyard telescope, and you can even see the rings on Saturn. But anyway, Saturn is 750 times the size of Earth. And it's less dense than water. The entire planet. If you had a bathtub big enough, Saturn would float.
Really? Well,
Yeah.
we took out, my husband got me a telescope a few years back. And so every once in a while we take it out. And I think, was it Jupiter that came around just the last few, whatever. Well, my telescope is strong enough to where you could kind of see maybe a little bit of the blur of it. But Yeah, so we take my telescope out every once in a while. We're a telescope, like, metal detecting kind of family. We
Oh,
love
okay.
doing that stuff. So I mean, we're
Well,
always searching for treasure and trying to find cool stuff,
the very first time we ever discovered volcanic activity away from Earth was on the moon Io. In 1978, we sent a probe called Voyager to take pictures of the outer planets, and it accidentally caught a photograph of Io as it was erupting, and
That's super cool.
you can see it against the background of Jupiter. You see this volcanic plume rising up from the moon, and it's just gorgeous. And Saturn, as large as it is actually fluffy.
Oh,
Like I said, it's less dense than water, and of all the moons in our solar system, we think that one of the moons of Saturn might be a likely location for us to set up a colony.
really?
The moon Titan is approximately 1.5 times the size of our moon. Our moon is about 2,000 miles across. Titan is about 3,000 miles across. And Titan has an atmosphere. It's not breathable for humans, but it has an atmosphere. The important thing is that atmosphere provides pressure on the surface of the moon. So if we were to build, like I say, a building, the pressure on Titan is similar to Earth. So you wouldn't need, heavy, because if you put something on the surface of, say, the moon or Mars, there's very little pressure. So the reason the building has to be constructed very strong is because the atmosphere inside the building necessary for you to live is going to push outward against those walls. And those walls had better be pretty strong to withstand that pressure, because its natural tendency is going to want to be to explode the building and push outward. So buildings have to be specifically designed to withstand that kind of pressure. Well, on Titan, you don't have that worry. The only thing you got to worry about on Titan is the temperature. It's about minus 150 degrees on the surface.
Yeah.
So, temperature we can deal with.
Yeah.
Pressure is something entirely different. So we think there's a good chance we can put some body on the surface of Titan with relatively minimal technology involved. And we're interested in Titan because Titan also has geologic features on it that look as if they were carved by running water. The problem with it is Titan does not have any water. So how did that happen? Well, the surface is covered in liquid natural gas. There are lakes located on Titan that are about the size of the Great Lakes in the United States. And instead of water, they're completely filled with natural gas. So the cycle of here on Earth, we have what's called a water cycle. The water starts in the oceans, it evaporates, creates clouds, and then it rains back down on your head. Water cycle. Well, on Titan, it's a methane cycle. It actually rains methane.
That's crazy.
Because in the early 2000s, we sent a spacecraft to Saturn, and it actually orbited Saturn for about 10 years. And it explored the rings, and it explored the moons. And it was called Cassini. The satellite was called Cassini. And it carried with it a smaller satellite, which it dropped and eventually parachuted down to the surface of Titan and was taking photographs all the way down. And that's how yeah, that's how we saw all of these features that looked like they had been carved by water. We actually landed on the surface of it. We took photographs of it. The other thing we saw was one of Saturn's moons. It's called Enceladus. We caught Enceladus erupting, and it was erupting water into space. And that water was being caught by Saturn's gravity, and it was falling into the rings. It was feeding the rings. It was actually replenishing the rings with, because the rings are made up of ice, water ice, like you get out of your refrigerator. And so Enceladus was feeding one of the outer rings. And the reason these small moons, even like the ones surrounding Jupiter, are erupting is not because they have a core like we do that is generating heat energy and it's escaping out through volcanoes. No. Jupiter is so large compared to Io. Io's orbit, like most objects in the solar system, are not perfect circles. So at some point they're a little closer, at another time they're a little bit further away. Well, Jupiter's gravity is so intense that that little bit of change in difference is basically squeezing the moon like you would squeeze putty in your hands. And it's creating friction on the interior of that moon, which in turn is creating volcanic activity. And that's what's happening on Enceladus as it goes around Saturn. Its orbit is slightly elliptical, so there's some stretching that occurs because of the gravity changes. And that heat is generating these volcanic eruptions. And Enceladus is made up mostly of ice.
Wow.
So its volcanoes are ice volcanoes.
That is so interesting. I did not know that. I'm sure my mom's going to get a kick out of that.
Uranus is laying over on its side. It's tilted at 98 degrees. And Uranus is about 12 times bigger than Earth.
Mm-hmm.
So you can imagine the object it took to knock that planet over.
Oh, definitely.
It was a rather huge impact to knock something over like that. And the mystery was Uranus has a ring around it like Saturn.
Mm-hmm.
And so the big mystery is it appears that the planet was knocked over, but the rings and all of Uranus's moons went over with it. So everything is orbiting Uranus around its equator, which is tilted.
Mm-hmm.
And so they think that the collision that happened with Uranus wasn't a single huge destructive impact. They believe it was a series of smaller impacts that kept nudging it over and over and over. Otherwise, the rings and the moons would not have been able to follow along.
Right.
And then when we flew by Neptune, the big mystery with Neptune is that it has the fastest wind speeds in the solar system. The fastest wind on Earth ever recorded was something like 220 miles an hour. And the wind speeds on Neptune are 1,500 miles an hour. And the mystery is, in order to get wind speeds that quickly, you need a heat source. Mm-hmm. And Neptune is too far away from the sun. So where the hell is the heat coming from? And they've recently discovered that it's coming from the interior of Neptune. There's heat escaping from the middle of Neptune, and it's driving these winds. There's just a whole lot of interesting history of our solar system that what I've been telling you in the last 20 minutes, we've only discovered in the last 25 years.
Right.
through advances in modern technology, you know. And so we recently flew by Pluto. We did that about 6 years ago.
I was going to
And-
ask about that. I was born in 1981.
Uh-huh.
And so I've heard it was a planet and then it wasn't a planet and then it was a planet. And then, so I don't know.
The reason is it's actually smaller than our moon.
Mm-hmm.
And so the reason for the argument about is it a planet or not is it's got to be big enough to, in order to be a full-fledged planet, it's got to be big enough and to hold on to an atmosphere.
Mm-hmm.
And Pluto doesn't have one. And there's no, well, it also has to have some kind of tectonic activity. Tectonic activity is necessary for life. And I know that sounds kind of strange, but it has to do with the recycling of material. Well, anyway, we discovered that Pluto does indeed have tectonic activity, but it's nothing like you would expect here on Earth. Our volcanoes erupt basically melted Earth, molten magma. Okay, it appears, because the temperatures on the surface of Pluto are probably in the minus 350 degree range, that's cold enough to freeze oxygen into a solid.
Mm-hmm.
And most other gases turn into a solid. And so what we discovered is that there's a lot of nitrogen on the surface of Pluto. And we've discovered that the tectonic activity that's occurring on Pluto is occurring with nitrogen. It doesn't take much of a change in temperature for nitrogen to go from a solid to a liquid and back again. And so on Pluto, you have this change in state from liquid to solid and back and forth again, depending on Pluto's orbit. Where is it in relation to the sun? Because nitrogen turns into a gas just a few degrees above minus 350. So it's that tight of a set of parameters. And so there's movement on the surface of Pluto. And one of the ways astronomers can gauge the age of a landscape is by looking at how many impact craters are on the surface. If there's a lot of impact craters on the surface, it means that world is probably geologically dead. And those craters have been there for a pretty long time. If the surface of the planet looks relatively smooth, there's been tectonic activity. There's been a weathering process of some kind that has erased the evidence of those craters. So the reason you see craters on the moon is because there's no atmosphere to erase them.
Mm-hmm.
So those craters are really, really old. And that's how we're discovering the history of our solar system. So when the Apollo astronauts returned back from the moon and they brought rocks back with them, they discovered that the rocks they brought with them are identical to Earth's crust. The moon was physically attached to the Earth at one time in the past. A huge impact blew the crust of the Earth off into space and it became the moon. And so once the moon formed, it then was able to hold Earth's tilt at 23.5 degrees. And the moon, despite the fact that it's 250,000 miles away, Earth's gravity is strong enough that even though the moon rotates, it always appears to have the same side facing towards us. When that occurs, the moon is said to be tidally locked. What this means is that its rotation is the same as its orbit around the Earth. The speed, I mean.
Mm-hmm.
So that makes it appear that the same side of the moon faces us all the time. And it does, because Earth's gravity is holding it. And so you never see the dark side of the moon. And it wasn't until the 1970s that we took a photograph for the first time of the dark side of the moon, and it looks drastically different than what you see on this side. They discovered an impact crater on the other side of the moon that is nearly 1,000 miles wide. And if the other side of the moon were facing us, I play some mental gymnastics with friends from time to time. If you look at a photograph of the dark side of the moon, it almost looks like a giant eyeball looking at you. Can you imagine if that side of the moon had been facing Earth? How that would have affected the various religious faiths on this planet if they thought somebody was constantly looking down on them?
There'd be no sin.
Yeah, exactly. So, yeah, and
that's
I find this stuff exciting because it's new. We're just now
Yeah.
discovering all this, and it's going to get better. We're putting up another telescope here soon. I think it's going to happen later this year. You can Google this too. It's the James Webb Space Telescope, and it's going to have the ability to see even further than the Hubble. And it's going to do so more accurately.
So does that mean that the 13.8 billion is
we may that light horizon might possibly be pushed further, and then of course the big mystery is what the hell is out there. Whenever they look at objects that are that far away, they're actually seeing the earliest days of the universe.
Mhm.
So what they're looking at when they see in that distance is they're seeing some of the very first galaxies ever formed in this universe. And they don't look like anything that you see here close by. They look different. And so that's why astronomers are so fascinated by them, because they want to know how stars first formed and how galaxies first formed. And they can only do that by looking way, way out there.
Yeah.
And so they're discovering that these galaxies don't resemble anything close by. And so there's a process involved that they don't understand yet. How do galaxies form? Because something else that's brand new in just the last 25 years, we've discovered that the vast majority of the galaxies in the universe at their center have a rather large black hole. So what's with that? Is it necessary to form a galaxy? We don't know.
Yeah.
And these black holes are absolutely monsters. You know, we have one galaxy. And so what we're discovering, have you heard of a concept called the Goldilocks zone? Do you know what that is?
Mm-mm. I've never heard of that.
When we look for life in other solar systems, the planet, whatever this is, it can't be too close and it can't be too far away from its sun. It has to be at just the right distance to keep water liquid. And it's called the Goldilocks zone. And it's different for every solar system because every star in the universe has slightly different characteristics. Our sun turns out to be an average sized star in every aspect. The majority of stars in the universe are actually smaller than our sun. But there are some monsters out there that are hundreds of times larger than our sun. So anyway, we've also discovered that not only is there a Goldilocks zone as you orbit your sun, there's a Goldilocks zone as it applies to the galaxy at large. You cannot be too close to the center of the galaxy because of this black hole and the kind of stars that are located near this black hole. There's an intense amounts of radiation in that region of the galaxy, and human life as we understand it would not survive living near the core. It's possible that there could be life in the core of our galaxy, but obviously it will have had to adapt to all of that radiation. So who knows what that kind of life would look like. You cannot live too far on the outer edge of our galaxy for the same reason, well, almost the opposite reasons. It's almost like you need a little bit of the protection of our galaxy. And when you live on the outer edges of it, what this means is your solar system is susceptible to the gravitational waves created by our galaxy as it rotates. In other words, it could easily sling you off into outer space. So you want to be somewhere in the middle in every regards. And well, fortunately, that's where we are. We are in the middle. And so if we're going to look for life that even remotely resembles Homo sapiens, it's going to be in this zone, because our physiology will not tolerate anything else, really. I mean, when we go to look for other planets to live on, that planet, like I said earlier, it has to very, very closely, if not exactly, mimic the environment we're currently in. Otherwise, we're going to have to adapt. And it sounds so whimsical. The gravity has to be similar. It has to have the right temperatures to keep water liquid. There has to be carbon on the planet to, there's a carbon cycle as well. Plant carbohydrates are food source. It has to be there. You know what else has to be there? Time. If let's just say that planet is 1.5 times the size of Earth, which is common. We've actually found Earth-like planets, but they're a lot bigger than us. And so that means their gravity is more intense. That also means time runs slower on that planet. So if we choose to live there, our biorhythms are going to have to adapt to the fact that that planet might have a 36 or a 48-hour day. And so, generations of human beings living on that environment are, after 5, 6, 7 generations, they're not going to resemble Earthlings anymore. There's going to be adaptations made. And so if we're going to locate another planet to live on, it had better damn well come close to whatever the Earth is. It has to have tectonic activity. It has to be roughly the same size. It has to be just the right distance from the sun. It has to have water. It has to have a carbon cycle. Otherwise, it's going to be all man-made. It has to be. So
that's so interesting. Yeah. Well, I gotta, my kids are gonna start getting crazy here in a second.
I understand. But
no, I gotta call my mom anyways to tell her about my statistics final. But I took some notes of what you were saying, this because she would think it was interesting. So my mom's 73 years old, and so she was there when the moon landing happened. She got to watch it.
So did I.
Yeah. And
I'm not far behind your mom, dear.
But so she's all into this stuff, and it was so interesting. I bet you if you guys got together and talked about this stuff, you'd be there for 6 hours or more.
Well, the astronauts were my generation's version of heroes.
Oh yeah. No, that's my second to youngest. This is David.
Hi, David.
So this is Matthew. But
hi, Matt.
All right. Well, we'll see you later.
Okay. Bye-bye.
All right. Bye.
Yes. Jack, as we go around the sun, our distance from the sun changes on a daily basis. Okay? Let's just say you live in Visalia. The reason that the seasons change is not the changing distance from the sun. It's the angle at which you receive sunlight. The angle at which you receive sunlight today is not going to be the same tomorrow. So every day, the angle at which you receive sunlight changes. It's the change in that angle that creates the change in seasons, not the changing distance from the sun. The angle of the sunlight, that's what makes the difference between summer and winter. It's related, Jack, it's related to solar angle. And if you wanted to calculate what today's solar angle is going to be, you would need to use that figure 8 pattern. But I did not tell you how to use it, and there are no problem-solving questions on this first exam. Okay? Yeah, the figure 8 is reference material. If you notice, Jack, the shape of the figure 8 is not a perfect figure 8. It's a little bigger on the bottom and a little smaller on top. That is because we do not go around the sun in a perfect circle. If we did, that would be a perfect figure 8. So we are slightly elliptical in our orbit, and the fact that that figure 8 pattern is not equal between the top and the bottom is a reflection of Earth's elliptical orbit. But yeah, sure. I'll see you next week. Hey, bye-bye.